Hello guys, this is Viera from Viera Manufacturing Services. Welcome back to the tech tutorial. So guys, in this tutorial we are going to be speaking about generation of the M&G code. So we've successfully designed the VMS project 1. So right now we have to convert this design into M&G codes that can easily be understood by the CNC operator. So let's get started. So first thing, one thing you should ask yourself is, are you going to use a CNC milling system or a CNC turning system? So clearly from this drawing, it's a milling system we are going to use. So let's just dive into it. So they come, right? New, milling. Okay, so these are steps you have to do for any mechanical part you are trying to generate the M&G code. Okay, so CAM part name VMS project 1. I'm fine with this. You can edit the name as you wish. Directory, you could choose a directory. Unit, very important. So this design was done in millimeters, so I'm gonna be using metric. Okay, so we have external and we have internal. So one thing, this is known as the tree, right? And this tree contains all the features of the design, being it the extrude, being it the fillet, being it the hole. It contains all the features. So if you are using internal, so be aware that the CAM features is going to be under this tree. So it's going to be embedded with the SolidWorks features. So meaning that the CAM and the SolidWorks will be embedded under this tree. So if it's embedded, definitely you can easily manage it. However, it makes your project file very heavy. So you need to have a good computer in order to handle that. So if you are using external, guys, the CAM feature will be, embedded into another file different from this. So it means you are going to have two different files, one for the design and one for the manufacturing or for the CAM. Okay, so I'm gonna go with internal. Okay, so we have CNC machine. So right now you could choose your CNC controller. We have different CNC controllers, just like we have G Milling 3X, which is a default controller. We have Fanuc, we have Siemens, we have Torch. We have so many CNC controllers. So just look upon the CNC controller you are using in your industry and just select it over here. So I'm going to be using the default CNC controller G Milling 3X. Okay, so we have, let me just go down here. We have program number. So let me just edit it, just double click on it. I can put program number 1. Okay, fine. Program number 1. Okay, so we have coordinate system. So guys, in any CAM part which you are doing, you need to define the coordinate system, the stock, and the target. These three things should always be done, and of course the CNC controller. These 4 things should always be done. So the coordinate system is just the offset, what is known as offset. So you have to tell the machine exactly where the workpiece is, because definitely this is a workpiece, right? But the machine doesn't know that the workpiece begins from here. So you are responsible to tell the machine that the workpiece begins from here. And by the way, we can select many different different types of offset. Or it's not just about putting one offset. We can put other offset, maybe like up to 8 offsets. Okay, so to put an offset, we are going to tell the machine that okay, this is the part and the cutting tool has to begin from here, because remember that in a 3-axis milling machine, the cutting tool moves from upward to downward, that is in the Z direction. Okay, so select face, select surface. Okay, so one thing you should know is Z should be up and X should be perpendicular to it. Perfect. So this way, guys, this way. So if it's not in this manner, just go down here. Now you can just play with this. Just look, if I flip around Z, you see it just flips. So making sure that it should be in this direction. So that's fine. So offset done. Okay, just click on the green check, take some time. Okay, so right now let's speak about the stock definition. So the stock definition, guys, is simply the solid block, or what is referred to as the workpiece or the raw material. So which raw material can we use for this particular design in real life? Which raw material? Is it a circular raw material? Is it a rectangle? Which raw material are we going to be using? So based on that, we have several definitions like box, extrude boundary, 3D model, cylinder, and of course TSL. So but right now we are just going to be speaking about box and of course cylinder. So taking cylinder for example, taking absolute coordinate. Absolute coordinate means it's the precise dimension. It takes a fixed dimension with which you draw the diagram in SolidWorks. Okay, so just come down, take model dimension. Okay, so as you notice, it leaves a lot of gap. Oh, so when it leaves a lot of gap, be aware that this is not the right stock. It means in real life, if I'm using a circular raw material in order to design this particular part in my CNC machine, it's not going to be good. It's not going to be good at all. Okay, so the raw material isn't good. You have to change the raw material. Let's take box, absolute coordinate selected, take model dimension. Okay, pretty good. Less space, so you have to take the raw material that leaves left space. So this is good, right? Okay, fine. So just click OK. So right now target is selected by default, but we can select it by ourselves manually. So I'll just delete this on select. Then as target, you have to take the CAM selection, the CAD selection. That is the CAD model, which in this case is this. Just click anywhere on the model. Okay, good. Okay, fine. Okay, so this place is for iMachinery. There's something known as iMachinery. We are going to see it in the future lessons. Okay, so we are pretty good. Okay, fine. I think the basic has been done. Okay, so right now we are going to be speaking about basically the first operation generally perform on any part. This first operation is known as facing. So facing operation helps us actually to move the raw material at the surface generally. So sometimes when a workpiece comes, it comes with a lot of dirt, a lot of roasting. So in order to remove all this roasting, we have to use facing operation. So we are going to remove the excess material at the particular surface. So to do facing operation, you use a face mill. So let's just drive into it. SolidCam 2.5D. By the way, we have SolidCam 2.5D and SolidCam 3D. So SolidCam 2.5D is actually used to machine 2D two-path, and SolidCam 3D is used to measure 3D two-path. So we have SolidCam multi-ax, and this SolidCam multi-ax is actually used for 5-ax machinery. So right now we are dealing with 3-ax machinery. Okay, so SolidCam 2.5D face. Okay, let me just drag this. I'm using two screens, guys. Okay, fine. Geometric remains unchanged. Tool, select tool. Okay, face mill. Oh, let me drag this. Okay, so face mill. Okay, let me do one thing. Edit or view. Where is that in settings? Okay, let me just uncheck this right quick. Yeah, safe. I don't know, there's an issue. View, settings, auto add tool. Okay, fine, it's fine. Okay guys, so I'm using a face mill, right? I'm going to swap this to inches. I'm going to use a face mill of 2 inch. Now you have to equally, this is diameter of 2 inch, so I'm going to edit the length equally the length of the tool. Let's say 5 inch. Okay, so we have the tool holder, right? Let me just say okay firstly. So this is what this black place is, the tool holder. So you can select any tool holder you wish. Okay, just click on this, open default tool component. Okay, so we have different tool holder. So these are the tool holder used for mailing. So you can just select anyone, okay. Okay, it's fine. Come to data. So on the data you can edit your feed rate and your speed rate. So we are not going to speak about this, it's pretty good this way. So we have coolant. So any of the coolant in green, you have to check it. So it's very important to check this coolant. Okay, to change or find levels, upper level, we are going to be facing from here. Okay, face depth. Now for the face depth, we are going to be using a finishing surface of say 0.01. okay, equal step down of 0.04. This is actually the maximum step down you can have. It varies from 0.01 to 0.04. So I'm using this maximum. Okay, data, we are going to see this later on. So we have technology. I'm going to be using, let's use quantum. Let me show you guys something. Quantum first. Okay, it's pretty that. Link or find. Okay, so we have save. I can save. So this second one, it's save and calculate. It means it's save and simulate, right, the operation. Okay, it's pretty that. So this one is save and calculate with related operation. It means if you do one or two operations, then you have to use save and calculate, right, with related. So we have save and calculate, save, parallel, calculate, and quick. So just look, if I click on this one, you see it's calculating, right, but in the meantime I can be doing other things. So right now it's still calculating, but in the meantime I can be doing other things. It doesn't affect me. So this is the advantage. But remember, when you use save in parallel, it takes a longer time actually to calculate. So that's just one of the disadvantages equally. So just clicking back, right clicking here, just click on simulate. Oh, let me drag this back here. Okay, so this particular simulation data, you could off it here or see back on it here. Okay, so let's verify. Let me just put this out of the way. Okay, so this is the simulation speed. You could reduce it, just play with it as you wish. Okay, play simulation. Okay, let me play again. Good. So you notice this may take, let's say, 5 seconds. Okay, just look at difference. So cancel. Okay, just come back here, right click, edit. No, sorry, edit. Okay, fine. Technology, I'm gonna be using hash. So when the raw material is a rectangle or a rectangular block, it's very important to use hash for surface finishing, because hash actually helps in the case of rectangle only. It makes the surface finishing more fast as compared to quantum. So if the raw material is cylindrical in a cylinder form, quantum is going to be useful at that moment, because quantum actually finishes from inside to outside in a circular manner, as you saw before. So we have hash 2% should always be 50. Okay, so this flow offset is actually used for roughing, so I don't want roughing here. It's okay. Hash, this should be automatic. Okay, or fine. Link, face, none. Okay, good. Save, calculate, simulate, solely verify. Okay, play. So as you notice, for the same speed, guys, from the same simulation speed, it goes more fast with hash. So please, guys, when you're using rectangular block, use hash. If you're using circular block, then use quantum. Hope you got that. Okay, so it's fine. Okay, so what next? So guys, now we have to speak about how can we do this inner place. So by the way, this inner place is known as a pocket operation. It's known as a pocket operation. So we are going to use pocket. Just click here, pocket. Okay, now we have a coordinate system, Mark 1, that's the offset. So now this, you have to click here, new. So now right now you have to, select the pocket. You have to tell the machine that, okay, I want to machine this particular place, this particular pocket. So this is the pocket here, so I'm going to select this place. Okay, good. So this pops up, so yes. Okay, good. So you just see the pocket is beautiful selected. Okay, good. So now you have to select the tool, select. So now for a pocket, when you are machining a pocket, you have to use an end mill. For proper face finishing, you use a face mill. For pocket, you use end mill. So we click on end mill, swap. I'm gonna be using an end mill of, let's say, 0.5 inch. Okay, let me edit the tool length to 5. Okay, I think it's pretty that fine. Okay, coolant. So just check this green one. Okay, good. Levels, upper level. The pocket begins from here. Good. So you notice that this pocket depth, right now it's 25, right? And our depth is actually 25. But you will notice that when I will select the pocket depth, what you are going to notice is it's going to become green, meaning that I'm selecting the right one. So pocket depth, so up to here. Okay, fine, good. So it's green, meaning that I'm selecting the actual one. If it isn't green, then just know that you're making a mistake. Okay, equal step down. I'm going to be using step down of maximum 0.04. Okay, I think it's good. Technology, quantum, it's okay because it goes in a circular form, so this technology quantum is fine for us. Okay, wall offset, I'm going to be using an offset, a roughing, let's say 0.01. Floor offset 0.01. Let me just remove this, and then a finishing pass, and equally a floor finishing pass. Okay, all fine. Number of passes, 1, fine. Quantum, all good. I think it's pretty good. Link, none. Okay, good. Simulation done. So rest material. Okay, good. So we have to machine this particular area, this two part. Before that, let's look at something, guys. We use 0.5 inch tool, an end mill of 0.5 inch. So but right now you see this end mill of 0.5 is actually too big to actually machine this particular fillet. So we have to use a more smaller end mill, let's say 0.2 inch. So let me show you guys how to do that. Okay, just close this. Okay, you could just off this, just untick it, so it offs. Okay, just come back to quantum. Okay, right click, edit, take some time. Okay, so guys, come over here, save and copy. So what this does is like it's going to save this particular operation and open a new windows of the same operation. So it just saves and it copies another. Okay, save, copy. Okay, good. So here it is, right? So geometry, same geometry selected already, show. So as you notice, same geometry selected, fine. So what we are going, the tool right now is 0.5 inch. So we are going to modify the tool. We take a more smaller tool. Okay, click again on end mill. Okay, swap 0.2 is fine. Okay, one thing I want to say here, it's like the tool holder comes automatically. So in order to do that, you just have to come on view, settings, and just click auto add adapter holder, and you save and you exit. So right now I'm just going to exit. Okay, good. Okay, the length, let's say 5. Number of feet, 2 is okay. Okay, all fine. Okay, coolant, you have to on the coolant. Okay, good. Data fine, all fine. Levels, same level, remains unchanged. Step down, same. Technology, so here's the magic here. So right now, you know, we have to machine back this particular pocket, right, using a smaller tool. Okay, so but if you know we have to machine it once again, it will take a lot of time. So what we are going to do is, at this particular place, we are going to select rest. It means this particular 0.2 tool or this particular smaller tool will only machine what wasn't machined. So it's just going to focus only on the fillet. Okay guys, so previous tool, the previous tool we use is 0.5. so you select 2. Okay, previous wall offset, you could just check it over here, technology. So wall offset 0, so it just remains 0. Okay, good. Separate area, none, all good. Save, calculate. Okay, let's look at this. Okay, simulate, solid verify. Okay, so as you notice, it focused only on the fillet, right, what wasn't machined by the 0.5 end mill. Okay, all good, looks nice, all is going on fine. Okay, it takes some time. Okay, good. So rest material. Okay, as you notice, this is actually mill. Okay, good so far. So we have to machine this particular part. Let's look at this. Okay, close this. So for this part, it's equally a pocket operation. So just click on. Let me just pull this down. Let me look at this. Okay, good. Looks nice this way. So I'll just untick this. Okay, pocket. Okay, you have to select the you know, tell the software where the pocket is. So here it's the pocket. Good. So and equally the other side. Fine. Tick. Okay. Tool. I think I'm gonna be using a, let me just use the more smaller tool, 0.2. Okay. Okay, coolant on. Okay, fine. Levels, upper level, it begins from here. Pocket depth up to this point 20. Good. You see the software actually guides you totally. So step down, I'm going to use a scepter of 0.04. Okay, technology, I'm going to be using wall offset 0.01, floor offset 0.1. I'll finish it and equally finish the floor. Okay, good, all seems good. Okay, fine. None. Okay, save, calculate. Okay, then simulate, solid verify. Okay, play. Okay, perfect, all looks good. It's taking some time. Guys, I hope this project 1 VMS is actually interesting, guys. So with this operation, for sure you are going to learn many CNC operation. So right now we have learned face operation, facing, pocket. So equally we are going to learn profile soon, and exactly, you know, even drilling operation will be learned from this project. Okay, almost done. Yeah, the finishing is properly done. Good. Okay, rest material. Oh, nice. Wow, properly done, guys. Perfect. Okay, all this red mark, you know, we are going to look at this later on. Okay, let's just focus on bigger things. Okay guys, look at this external part. Now let me just close this. Okay, just off this, close this. Now in CNC world, right, when you are machining the external portion of a part, we call that profile operation. Anytime you machine the external profile or portion of a part, it's known as profile operation. So let's just go. This is profile operation. Equally, you could just come on operation, guys, right click, just find add milling operations. Good. Profile operation, hope you got that. Perfect. Profile, take some time. So you need to tell the machine where is the profile. Okay, so this is the external part, so I will select this. Good. So you see the way it takes. Perfect. Okay, what next? Tool. Let's just use 0.5 inch. Okay, making sure our coolant to be on. Okay, fine. We don't have a tool holder. What happened? We don't have a tool holder. Let me just take that, select. We have no tool holder over here. I think, but in a tool we have tool holder. This is automatically checked, case software issue. Okay, never mind, it's fine. Levels, this upper level. Good. Pocket depth up to the end. Perfect. Okay, so now guys, if you are making a profile operation outside, right, you are making a profile operation, so up to this end, sometimes we have what we call chips, right? Sometimes due to improper finishing, there are some remaining chips. So in order to remove this chip, you need to go, you know, like you are going up to 25. So for proper finishing, you just go up to 26, right? So for that, you just have to put -1 in data. Just add -1. It means the depth will go up to 26. Okay, so if you are putting 1, you see the arrow goes upward. It means it's going to machine up to 24 rather. Hope you got that. So we are going -1, so it machine up to 26. Okay, fine. So geometry, it's very important to check this geometry. Okay, good. So if I take right, you see it will machine inside. Definitely there's going to be two collision in this case. If I take center, similarly two collision. So the perfect here is left, with left or fine. Good. So I can just edit this equally. You see start point, if I say 5, oh no, let me try 1. No, I think it's, in this case seems like will not work. Okay, good. So you notice, just try and work up. If I'm taking -5, you notice the variation happens, right? So but in this case 0 is actually good for us. Okay, so fine. So step down, roughing, well offset of 0.01, flow offset of 0.01. You could put 0.02, no issue. Step down 0.04. Okay, extension, I'm going to take an extension of 10. Step down 0.04. Okay, so far good. Okay, I think that's it. Link. Okay, so for profile operation, make sure that the lead in should always be normal, and it should have a value ranging from 0.01 to 0.04. Okay, and equally same as lead in. Okay, good. Okay, so far good. Save, calculate. Okay, simulate, solely verify. Okay, play. Oh, it's doing it good, but you know, we are having some, you know, raw material over here. Okay, we have to, you know, think on how to move this raw material. Okay, you see, we're having this raw material left over here. Okay, so this is the finishing pass. The first pass was done, that is roughing. So now we have a finishing pass. Okay, good. So over here, you know, we have the time, the compensation, the spindle. You know, the spindle right now is clockwise. The spindle speed, the RPM, the feed rate. Okay, rest material. Okay, you notice it's nice, but okay, it's looking really good. It's even almost done, but we have these guys, we have this. So how can we remove this? I don't know what happened. It's not going off. Okay, let's just cancel this. Okay, geometry tool, levels, all looks good, all looks good. Okay, all looks good, guys. Okay, one thing, just come back on tool, guys, select. So anytime this kind of scenarios happens, it means the tool is actually small, right? So just come on that tool, click and mill. Okay, you notice that the holder comes back, so it means this, you know, just software issue. So for tool swap, we are going to use an end mill of 1 in this case. Okay, length 5. Oh, fine. Okay, okay, fine. Okay, coolant, put the coolant rapidly on. Okay, all good. Levels, so it's okay, fine. Just modify the tool, guys. We are using the tool of 1 inch. Save, calculate. Okay, takes a little bit more time. Okay, simulate, solid verify, play. Okay, looks pretty good. So anytime such an, you know, incidents happen, then make sure you use a tool of a bigger tool. Just use a bigger tool and the issue will be solved. Okay, the finishing pass. Okay, it's like, you know, it's actually more fast. You see, X, Y, Z, it shows the direction of the tool equally. Okay, rest material. Oh, nice, perfect, almost done. So guys, now one thing, as earlier said, this is a 3-axis, you know, milling operation. So the tool, or let's say the tool turret, it moves from upward to downward, that is in the Z direction, right? So now it means it will not be able to machine this particular part, this side. It cannot machine this side unless if, you know, we rotate this, and again we define this particular side as the new offset or the new coordinate system. Okay, so it means we can have made many coordinate system in one drawing. Okay, so let's look at that. So this whole, can we do the whole right now, or we can do it later? Okay, let's do the holes right now. Okay, close, just off this. Let's take off the hose first. Okay, okay, just come on, drilling operation. Okay, new. So one thing you can do is like, you can select the hose 1, 2. You see, you can select it by yourself. Let me just take one select. You can just delete it, delete all. Oh, one thing you can do is just click on the surface. What happened? No drilling center in this box. Just cancel, new, select on the surface. Good. So when you select on the surface, it selects all for you automatically, all the holes on the surface. Okay, just click OK. Tool, select. So for drilling, we use either a center drill, or we have different tools like spark drill and so on. So I'm going to be using spark drill. One thing I forget to do is, okay, just put this down. Okay, good. Zoom this up. Come on, evaluate. Okay, sometimes evaluate can be locked. Just come over here, right click, tool, and then just if you tick this, it goes. As you notice, evaluate goes. So but if I untick this, it comes back in case yours is not present. Okay, so evaluate, measure. I'm going to measure the diameter of this hole. It's 7 mm. Okay, good. So all is 7 mm. So over here I have diameter of 7. The height, I'm going to take the height up to, let's say, 100. I hope it's okay. Yeah, 100 is pretty good. Okay, oh fine. Okay. Coolant on. Make sure the coolant should be on, especially in the drilling operation and tapping operation. Coolant should always be on, guys, for proper finishing. Now we have to holder collision protection. You could tick this. Okay, this actually it prevents the holder, this particular black place, from colliding with the workpiece. So by default we have a holder clearance of 0.5. so this holder will always be 0.5 from the piece, always, in case of collision, of course. Levels, upper level, the hole begins from here. Drill depth, okay, let's check. The drilling goes up to, okay, so this is the hole height, so it goes up to this place. Okay, yeah, something there. Okay, okay. Full diameter, technology, just leave this as default. Okay, all good. Save, calculate, simulate, solely verify. Okay, play. Okay, if I just slow down the speed, play, as you notice, it goes one after the other. Beautifully done. Speed up. Okay, that's material. Okay, so this is what we have, but it's not proper finish. As you notice, it's not finished properly. Okay, but we are going to finish this later on, because this out equally, these holes at the side affects this top hole. So later on we are going to finish this. Just be patient a little bit. Okay, so let's speak about how to machine this side view. Okay, so for this side view we have to define a new coordinate system. So to do that, just come above here, coordinate system manager, right click, open, add coordinate system. Same step, select face, define this as a new offset. Okay, good. Making sure the Z axis looks upward and X perpendicular to Z. Perfect. Okay, so you don't need to define the stock anymore. Only the coordinate system should be defined. You do not need to define the stock anymore. Okay, good. It's taking some time. Okay, so we notice 1 and 2. Okay, fine. So this part is equally known as a pocket operation. So solid cam 2.5D pocket. So we have to select the pocket. So this is a pocket we are machining. Let me just check something. It doesn't close. There's an issue. Okay, just tick up to entity. Now select again. No, not this way. Just unselect this. Let's try it again. Let me just cancel again. No. We have an issue. It doesn't want to close. I needed it to close, but it's okay, guys. Okay, let's try this. Okay. Do you want to close the chain with a line? Okay, perfect. Good. So now it's closing. But sometimes it closes directly. Okay. You know, the software is actually smart enough. Okay, all fine. Tool. Select tool. So we are going to be using, let's just take the 0.2 inch. Okay, good. 0.2 inch. Okay. Okay, coolant on, of course. Oh, fine. Levels. My levels. Right now, my levels will not be this, right? I'm working with the second offset. So right now, my level is this. Oh, there's an issue. Oh, there's an issue. Guys, just cancel this immediately. We make a mistake. Come back to geometry. Now, remember that we define a new coordinate system. So right now, our coordinate system should be Mach 2 and not Mach 1. Hope you got the difference. Good. So select again. Sorry for that mistake. Okay, good. Now you see it closed correctly. So anytime you don't select the proper coordinate system, you are going definitely to have an issue. Okay. Tool already selected. Our tool is fine. Levels, upper level selected. Pocket depth. This depth. Okay, good. Okay, step down. Let's say 0.04. Okay, technology. Quantum roughing 0.1 proper finishing. Okay, good, all good. Link none, just the same thing. Good. Calculate, simulate, solid verify, play. Okay, nice. Let me just increase the speed. Okay, I'm looking at this point. You notice the edge, right, guys? You notice that we are going to have some raw materials at this edge. Okay, rest. Okay, good. Ah, nice, beautiful done. Just this red spot, we have to remove this. Okay, we'll see how we can remove that later on. So let's machine this particular hole. Okay, so this slot, let's machine it. Close this. I'm gonna do save copy. Okay, good. So geometry, I will select a new geometry, which will be this inner hole. Good. Okay, let me just off this. Tool, I'm using the same tool. Coolant already off, of course. Good. Levels, upper level. The upper level of this particular slot, it begins here. You see it becomes green, meaning I'm selecting properly. Depth. This is the depth. Okay. So now what thing I will do is, like, if you notice, if the tool enters here, you know, it machines here. So for a proper finishing, rather of ending at, let me just select by the depth. Rather of ending at the depth of 8, I want it to go more deep, so it's going to end at the depth of 9. How do you explain this? Okay, step down, good. Technology, fine. Roughing, I think all is good from here. Okay, all good. Save, calculate, simulate, solid verify, play. Okay, all is going on fine. So we have to take care of, you know, these edges. So if we want to do these edges, what can we use? Profile operation for definitely. Yeah, we can use a profile operation. So rest material. Okay, beautifully done. So we are just left with these edges and equally these holes, right? These two holes at the end. what can we do? So for these edges, let's use profile operation. Let's just try it rapidly. Close this, untick this. Okay, profile operation, new. Oh, we have to check, right? Okay, good. Mark 2, then new. So now our issue is at this end, you know. So I'm going to select, let me just select from here. No, reject, cancel. Come over here, untick this and this, take up to entity. Now select by this point. Okay, now look at the direction of the arrow. It's going this way, right? And this is the direction I want it to go. So just click on this. So just look at this. If I change this reverse direction, it goes back this way. So but I want it to go from this side. So this direction is fine. So just click on this. It's going to complete it. You see? Good, good, and fine. I want it to end exactly here. Okay, so look at this, right? Okay, now the tool will machine from here. It goes this way, it goes this way, and I want it to go more deeper. I will show you guys how to extend it. Okay, tool, I'm going to be using 0.2 inch. Hope that will be fine. Okay, good. This selected. Levels, upper level, this point, lower level, this point. Okay, data should be 0. Technology, make sure it's inward. Right now it's outside, so it should be right, so that the tool can machine this part. Good. Okay, good. Just come down here. Now I want to extend this, because if the machine just, you know, look at where this particular circle is, it means the tool will end exactly there. Okay guys, the tool will end exactly there. So but I want the machine to actually machine it more deeper. So what I'm going to do is, let me just extend this to, let's say 5. Okay, good. You see it goes more deeper. Equally for the starting, let me take this to 5. Okay, all good. So offset on equally 0.05 or 1.01, 0.04, extension of 10, maximum step down. Okay, I think all it's fine. Okay, no issue. Profile, I set it normal, use 0.01. okay, sorry, same as let in. Okay, all done. Save, calculate, simulate, solid verify. Okay, let's look at this. Oh, good, it's actually doing it. Okay, good. Oh, I like it. It's actually doing it. Rest material. Oh, just press cancel. Okay, rest material. Let's check. Oh, nice, properly done. Okay, all good. Okay guys, so right now let's focus on this particular hose. Okay, just cancel this, cancel. So for the hose we use drilling. As you notice, it goes all through, right? Okay, so drilling operation, Mark 2 selected. So I just come over here. Okay, let me just rotate this. So I'm going to select this surface, hole 1, sorry, and hole 2. Okay, good. Select tool. Before that, make sure you check the diameter, evaluate, measure, dia of 10. Okay, so click. Let me just drag this. Drilling, spot drill, swap this. Oh, sorry, it's 10 millimeter, right? Okay, good. So let me just put this 100. Okay, I think it's good. Sometimes this is actually long. Okay, fine. levels, upper level from this point, degree depth to this point. Now that you know the hole is up to the end, I'm gonna be using a data. I'll just take a data. Let's just say data of, don't exaggerate a lot on this data. Let's say 0.1. It's okay, see, fine. Full dia, technology, just allow it the default, because over here we have more option, guy. I'm gonna be teaching this in the future tutorials, but with G81 cycle is actually good. Okay, motion controller, or fine. Save, calculate, simulate, solid verify. Let's look at this. Okay, play. Good. Where's material? Okay, so this site is totally done. Okay, oh, it looks nice. So let's walk about this site right now. Let's be fast a little bit. Okay, so this site is done. Look this side right now. Okay, so we need equally to define a coordinate system at this particular position. Okay, guys. Okay, let me just put this up. Coordinate system, open, add coordinate system, face this. Okay, let me rotate this. Okay, can just look this direction. Okay, good. Upward, Z, good, all fine. Okay. Take some time. Okay, so equally this is a pocket operation, so without wasting time, so they come 2.5D pocket. Now this is Mach 3, right? So we select Mach 3, then we select the pocket. So this is the pocket. Good. Okay, tool, let me just use that same tool, 0.2 inch to 3. Oh, fine. Levels, upper level, pocket depth, it goes up to this point. Now the pocket, it goes up to the end, so I'm gonna be using, there's no space, no extra material after this pocket, so I can go more deeper for a proper finishing. So I'm gonna be using a data, let's say of minus, let's say 0. Let me just play with it, 0.2. okay, step down, 0.05, good. Technology, or fine, roughing, just play with this. Okay, good, or fine. Passes, let me just take passes of 2 just to play with it. Good, or fine. Levels, or link, sorry, none. Good, or fine. Simulate, solid verify. Okay, let's do. Okay, all going on fine. Okay, it's taking a lot of time. Ooh, it's taking a lot of time. It's taking time. I didn't want this tutorial to be so long. It's taking a lot of time. Okay, up to 3 minutes over there. Okay. Oh, I think it's well done. Rest material. Okay, fine. Nice. So now we have this hole to drill. Let's look on this hole. Okay, fine, just cancel this. Let's focus on the hole right now. Drilling operation. So select this face, 1 and 2. Good. Dia, just ensure that dia is actually 10. I guess it's 10, but just ensure it. dia of 8. Okay, it's 8, not 10. Tool, you have to use a spark drill. This spark drill number 5 is dia of 7. This one is dia of 10. Okay, so we have to take a new spark drill, putting a dia of 8 millimeters. Okay, making sure coolant should be on. Levels, upper level, this point, 3 depth up to this point here. It finishes here. Okay, so it's at the end, right? So I can put proper finishing delta of, let's say 0.2. Okay, full diameter, technology or fine, save, calculate, simulate. Okay, rest material. Oh, good. Oh, nice. So this side equally done. So right now we have to, you know, define equally a coordinate system for this particular direction. Let me just flip it this way. Good. Okay, close this, close this, this close. Okay, let's define coordinate system now for this direction. Flip it this way. So just go back, same step guys, same step. Okay, open new, add coordinate system, select face, this face, okay, good. You see Z and then X, good. Okay, 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 all fine. So same thing, Mark 1, Mark 2, Mark 3, Mark 4. Okay, fine. So let's just go pocket operation again. New, making sure it's Mark 4, right? Just verify that. Okay, you see Mark 4, then new, this pocket, fine. Tool, or just use 0.2 inch. That tool, okay, coolant on, fine. Levels, upper level selected at 0, pocket depth up to this point. So right now, as you guess, I'm equally going to use the data for proper finishing. 0.01, sorry, minus 0.1 or 2, fine. Okay, all done. Link, none. Save, calculate. Okay, simulate. So verify. All done. This simulation takes a lot of time. So we are almost done with the VMS project 1. So the project 2 actually will be quite simple, guys. It's going to be quite simple. So this project 1 was actually a great foundation. I hope you guys understood this video. It was a great foundation towards using CAM software. So with this foundation, you know, any part you see, you must have an idea on how to start the part and what are the name of these various operations. Okay, fine. Rest material. Okay, so all is fine. So we need to machine this particular hole. Okay, let's look at the hole. Okay, drilling operation. Okay, new. One, two, good. Okay, I guess it's equally 8 if I'm not mistaken. Evaluate, measure, 8 dia, good. levels 2, sorry, 2 number 7. Okay, coolant, this on, level upper, data of minus 0.1, full dia. Okay, save, calculate, simulate, solid, verify, drill. Okay, rest material. Okay, all fine, good, very good. So we are almost done. So we have this side to make, so we have to put a coordinate system equally at this direction. After this hole, we have this inner part to finish, because we still have some lines here. Okay, let's stop this. Okay, we can also close this. We can just untick all these guys. Okay, all fine. So this holds our target right now, and it goes all through equally. Okay, just rotate this way. Okay, so go up, coordinate system, open, add surface, okay, all fine. Good. Okay, so we just have holes to do here. Let me just evaluate rapidly. Measure the holes. Oh no. Let me just zoom it. Okay, 10 mm. I think we have 10 mm drill already. Anyway, okay, let's take SolidCam 2.5D drilling operation. Okay, Mark 5. This surface selected. 1, 2, good. Tool. Let's check if we have a tool of 10 dia. Okay, good. Number 6 to 6 10 dia, so we select that tool. Coolant on. Okay, levels upper. Drilling depth. No, not this point, it's this point. 20, good. Okay, data minus 0.2 again. Full dia, technology, all good. Save, calculate, simulate, solid, verify, play. Okay, good. Where's material? Perfect. Oh wow, we are almost done, guys. Oh, we are almost done. So we are just left, to actually finish this inner part. Okay, guys, so far done. So right here we have to remove this particular place. Okay, so speaking about removing this raw material, or this red, this red spot, first of all, we use a tool made of 0.5 inch. We wasn't able to remove all these particular fillets, so we went down using a tool made of 0.2. So right now we are going to use 0.1 end mill, but rather we are going to be using a profile operation. So let's just try that. Profile. Okay, tool. Let's say geometry first. So we are using Mark 1 rather. New. Okay, just unselect this, take up to entity. So we are going to be finishing this particular place first. So we are going to take this line. Okay, starting from here to here, no issue. Okay, tool, let's use an enemy of 0.1. Let's drag this. Okay, swap 0.1 inch. Okay, fine. Okay, coolant on. Levels, upper level 0, fine. To this level, good. Technology, ensure it's inward. Right now it's out, so we are going to take right. Right, good. One thing more, step down, roughing 0.01. Okay. Okay, extension should stay 0. Remember, we always put extension of 10, but right now we do not need it to make a proper pass, so we are going to use an extension of 0 and then step down of 0.04. Okay, link, since this is a profile, we use normal 0.01, same as lit out. Okay, all fine. Save, calculate, simulate, solely verify. Okay, oh sorry, play. Okay, thing is fine. Okay, properly done, all good. Rest material, perfect. Okay, so we have to do for this other end, so we are going to use save copy. Very fast, save copy. The only thing we are going to change is actually, you know, the geometry. We are going to edit this. Now let's just flip the shape and you will choose this. Sorry, cancel, unselect this, up to entity, then this. Okay, levels up to this point. Again, we have to check geometry equally. Okay, the geometry is fine. Okay, all cool. Okay, all stays same, good. It's pretty that, right? Save, calculate, simulate, sorry, verify. Perfect. Rest material. Okay, all good, perfectly done. So now we were speaking about this point and this point. We could use, you know, same operation, profile operation. Let's just try that rapidly. Okay, cancel. Let me just edit this, guys. Edit. Okay, save, calculate, save and copy rather. Geometry, we interchange the geometry again. Okay, I think it extends more. Let's select this. No, cancel, up to entity. Okay, let's start from here. Now flip direction. Okay, then press this 3 out. Okay, just follow it up to here. Perfect. Okay, using the same tool, making sure the coolant should be on. Levels, we go up to the bottom, fine. Technology, making sure it's inward. Okay, right, good. So I think all is fine. Link, all fine. Save, calculate. Okay, yes. Simulate. So verify. Play. Let's check this. Okay, all is going on fine. That's material. Okay. We still have an issue over here. Okay, we'll just stop this now. Okay guys, so right now we are just left to machine this particular part. So we are equally going to be using a 0.1 n mil. So let's look at this profile operation. Oh, let's just do one thing. We can, save and copy. Okay, just cancel, edit, save, copy. Okay, geometry, we have to change the geometry. Okay, just untick this, up to entity. So this is the place we need to focus on. So I'm going to take this one. Okay, fine. Okay, tool 0.1 colon on or fine. Levels, depth, up to bottom. Good. Technology, let's check on technology. It needs to be inward, so okay, fine. Okay, equally, the two can collide with this part, so we have to reduce it a little bit more, and we take the starting a little bit more. Let's look at this. Let's take 2. Okay, for a proper finishing, 3 is good. And then the starting, let's take -3 equally. Let's take -4. Yeah, okay, good. -5 is perfect. And then here equally 5 is 5 good. Yeah, equally good. So 5 and -5 are good. Okay. Okay, all this remains unchanged. Link, all fine. Save, calculate. Simulate. Solve, verify. Okay. Oh, what happened? Just look at the way it's making it, drilling the inner part of the hole. Okay, means our geometry position is wrong. Let's just stop this. Okay, let's go back and check rapidly. Technology, geometry. Oh, look at this. It's kind of odd. Let me just check. Left. No, it's not well positioned. Okay, yeah. It's not well positioned. Let's just put this back at 0. Okay, I see it's not well positioned. Okay, just put it back at 0, 0. Let's observe. No, the end position, bring it back to -3. Okay, fine. Okay. I think the level is fine. Okay, save, calculate. Simulate. So verify. Okay. So it's going on fine right now. Okay, as you notice, it's not colliding with this other portion. Okay. Good. That's material. Okay. We are just having this part. I don't know why this part is appearing. Okay, we'll see about it. So rapidly save, calculate again. Okay, geometry, you have to change the geometry. Okay, we'll do for this portion, guys. Okay, let's, okay, good for this portion. Oh no, cancel, untick, untick, up to entity, then select this. Okay, levels, up to bottom. Oh, fine. Technology, let me just check geometry. It has to be inward. Okay, so right now it's outside, so we take up left. Would there be any collision? Our main point is here, avoiding this collision. So I think this should be the end point. So -5. Okay, yeah, good. Okay, I think all is fine. Save, calculate. Okay, simulate. Let's see this. So they verify. Okay, all is going on fine. Rest material. Okay, unfortunately we still have these edges. Okay, we'll see how to do about that. Okay, save, calculate. Okay, so similarly for the left hand side. Okay guys, so oh, what happened? My mouse is disturbing. Oh, computer freezing. Okay, so let's just delete this. Okay, edit. Okay, save or simulate rather. Rest material. Okay, so I expect you guys to do the similar step over here. Okay, one thing we have to do is we have to take care about this space. You know, I see like it's due to the hole, right? So we are going to go back to this particular operation and we'll go more deeper. Let's look at this. I think this was Mark 3. Let's just go to Mark 3. Okay, yeah, this Mark 3. So edit the hole. Let's go more deeper. Levels. Okay, so let's go more deeper. Let's say -1 to be precise. Okay, save, calculate. Simulate. So verify. Let's do it. Okay, rest material. Let's check on this. Okay, we have to, you know, check at the end. Just go back down at the end up to this end. Simulate. Solely verify. Oh, it will take some time. Right now it's just compiling all the operation, so it's going to take some time. Okay, good. Rest material. Okay, fine. Perfect. So you just need to edit that data and all is going to be fine. So same thing in this direction, guys. You have to do profile operation using this and equally edit the data. So right now we can just edit the data. So this is Mark, I think Mark 4. Just Mark 4. Okay, good. Mark 4. Edit. Let's take a data of -1. Okay, save, calculate. Oh, fine. Okay, let's just simulate it. Rest material. Good. Oh, fine. Perfect. So guys, here is the VMS project 1 completed. So one thing you have to see again is about the M&G code, right? So in order to obtain the M&G code, what you have to do is come over here, operation, right click, then calculate G code all, or just let's just take G code all, then generate. Now you can also generate with time, so I'm just generating simply. Okay, it's going to take some time in order to generate the code. Okay, so right now when it's going to generate the code, it's going to open what we call cement control. I think it is cement control. SQL simulator. Yeah, or equally it can open a notepad. So with this, guys, we are actually done with the VMS project 1. So guys, in the fourth tutorial, we are going to be speaking about the VMS project 2, guys. Chill up. Okay, so this is the M&G code properly generated in our Simco editor. Okay, so you can just copy this code using a pen drive into your CNC controller. Okay, guys. Okay, thank you, guys. Kindly like, share and subscribe the video. Meet you in the next tutorial.